will start by saying hello and thank you for being here. My name is Eli, and I'm going to be leading our webinar today, which is just going to be an introduction to pitop as a company and as an ecosystem of products. And also, it's been the name of several of our products. So a pitop introduction all around. A little bit about me. I work as our lead for community and content development. So that means that I work with our users as well as our team to create the content that is being used out in schools and homes and different places. And I kind of interface between those two groups, which means that I use our stuff a lot and I talk a lot to the people who are using our stuff. And I think a lot about the people who are using our stuff. So I spend a lot of time introducing this product. And so that was why when we started setting up these webinars, I said, I want to do one that's for anyone who's never encountered our stuff or who has maybe heard of it but doesn't know what it is. And I can just do a really simple, clean introduction to pitop. And so that's what we're going to be doing today. Before we do that, I'll start with kind of a general about, like an overview of where we were before and how we got to where we are now. So the first thing to know about pitop that I think is really interesting is that we created the first 3D printed laptop. It all starts with our founders. They met in college. They designed and 3D printed a laptop that was powered by the Raspberry Pi, and that's actually in the Guinness Book of World Records, which I think is super cool. And it goes from there to taking that initial design and turning it into a DIY laptop kit. And these kits were really popular in school and maker communities. There's a lot of support behind that. It was really exciting. Got a lot of people using Raspberry Pis who maybe wouldn't have or wouldn't have been able to before that. I still love that device. It's really cool. Their second crowdfunding campaign was to take what they learned from the Raspberry Pi DIY laptop and to build a $99 Raspberry Pi powered desktop computer called the pitop Seed. It's still to this day like one of my favorite Raspberry Pi gadgets in the world, and you see them being used everywhere where people are teaching with Raspberry Pis. It's so easy to grab one of those, throw it, in the back of your car or a bunch of them into a box and carry them into a classroom. And suddenly you've got a full Raspberry Pi powered classroom with computers that kids can code and make things with. And those are really, really cool. I absolutely love them. We went from there to a second, more powerful version of our laptop, streamlined the design, improved the components, very cool evolution of that product. Which leads us to where we are now, the current line of products, which is sort of the culmination of everything we learned from 3D printing laptops and building DIY kits and working with Raspberry Pi and education and with home users and schools, all sorts of places. And that leads us to where we are now. And so I'll be talking about that product ecosystem pretty much for the rest of the time that we're here. But right before that, I just want to say a little bit about, oh, there we go. Yeah, I want to say a little bit about who we are as a company. So pitop is a creative learning company with the goal of inspiring a generation of makers. And we do that by building modular technology. It's modular technology that can become and do all sorts of different things to promote learning by making both at home and in the classroom. So we want people to learn by making and doing things rather than just by reading and reciting and memorizing. And all of the learning that we promote is skills-based. We want people to learn skills that they can use in the real world. Memorizing facts is something that we can have computers do for us. So we want people to learn applicable skills that they can take out into the real world. And that's why all of the challenges and all the projects we design are built around real-world problems. And all of that stuff that I'm talking about starts with the Raspberry Pi powered pitop 4. And the pitop 4, like I said, is a modular piece of technology that is not really exactly like anything else out there. It's honestly, if you're not familiar with the device, it's kind of hard to wrap your brain around it at first because it can be and do so many different things. So the easiest way to start is the simplest way, I think, which is to think of it as a desktop computer. The pitop 4 can plug into a monitor, a keyboard, a mouse. You can connect it to a Wi-Fi or over Ethernet, and then suddenly you're up to the races exactly how you would be with any other desktop computer. So if you have a old computer lab equipment in a school that's maybe not being used anymore because it's been upgraded or something, you could take those components, attach them to this, and build a full makerspace computer lab using the pitop 4 as the desktop computer on top of it, doing the other things that it's able to do. But that's the simplest way of looking at it. The next way that I think is really interesting is you can also use it in conjunction with a laptop computer. So here what you see is a laptop computer, and the pitop is kind of borrowing the screen, keyboard, and trackpad of that device. So you can control the pitop from a laptop. And here we're seeing it done with our green display cable, which is able to connect those two devices. But if they're on the same Wi-Fi, you can actually connect them wirelessly. You can control the pitop wirelessly from any computer as long as they're on the same Wi-Fi. And we'll see that in the demonstration later. So this is probably like the simplest way to just really quickly start using it. And then maybe the coolest is that it can also sort of transform into its own standalone device where you don't need to borrow a screen and keyboard and trackpad from a laptop or connect it to a monitor and mouse and all of that. We have our own screen and keyboard kit, and with those, the pitop can become its own portable device with a form factor similar to like a Microsoft Surface device, where you've got a kickstand and a monitor, and then the keyboard and trackpad are attached to that. But as you can see here, the pitop can also just sit next to those devices. So if you wanted to access the pitop, rather than all of the internals being hidden behind the screen, they can actually be beside you so you can do projects with it as well. You can also detach the keyboard, and then it becomes something more akin to a tablet. That's a touch screen, so you can program touch screen games or interactions with it. A lot of flexibility there. And in fact, I would say that flexibility is sort of the name of the game when it comes to these different form factors with the pitop 4. If you want to use it in a computer lab setting, you can hook it up as a desktop. If your kids all have Chromebooks that they can just sit and use at their desk in a regular classroom, you can connect it to those. Or if you want to take it out in the field and you don't want to drag around all that extra stuff, you can just attach it to our screen and keyboard kit and use it as a standalone device. And that's really just the beginning of how it can be used, because there are actually ways well beyond this that we're going to talk about as well. But these are sort of the initial form factors that it's easy to think about. So this is what I meant when I said a modular piece of technology. But that modularity isn't really even the most interesting thing that it can do. The most interesting thing that the pitop 4 can do really comes from the accessories and the ecosystem that we have built around the device. And so that's the next thing that I want to talk about. And it starts, again, we'll start simple and move more complex as we go, but it starts with our electronics kit. The electronics kit is a collection of components, 14 electronics components packaged together in a really cool little metal bento box. Actually, I've got one here. Oh, I'm knocking stuff over. So, I've moved my bento box. I've got the lid of my bento box because I'm going to be using that in a minute. So I'll show you the full thing later, but it's a bento box of 14 electronics components that can totally transform the pitop from just being a computer that you would use maybe in the same way that you would use your desktop or your laptop or your tablet where you're browsing the internet and writing documents. It can transform it into something really different, where now you can connect lights and buzzers and buttons and sensors. And it goes from just being a computer to being a thing that monitors your plants to make sure that they're healthy, or it becomes a security system for your room that will alert you if someone comes in, or you can use it for prototyping smart homes by connecting all sorts of different gadgets and sensors to it. It really transforms into something totally different once you add that electronics kit. And we specifically are writing all sorts of projects and challenges to help beginners learn how to do that. So we're really interested in using this kit as a way to open the door for people to learn hands-on computer science, project-based learning with the pitop, with the electronics kit. So here we can see what that looks like. This is that kit, which again, I think is absolutely perfect for beginners. You can see there the LEDs, the ultrasonic sensor, the knobs, the buttons. And what's really cool about this kit, and it's in this picture, but it's very subtle, so it's hard to appreciate what it is, but at the bottom of all of those components, you'll see just these little black plates. And what I love about those plates is, I said, this is great for beginners to start prototyping and getting hands-on with electronics. Well, all of the components that you see there are magnetic. And that means that you could stick them on the fridge or stick them to other things, but they also will magnetically stick to those plates. And that's important because those plates connect to Lego. So when I said it's great for beginners to start prototyping, this is one of the ways that we've worked with that. There's no better beginner sort of construction prototyping kit than Lego. They're ubiquitous, everyone knows how to play with Lego. And so by building these plates and integrating them into that kit, you can take the construction that kids already know how to do and tie that into electronics prototyping in a way that's going to allow them to start building things that do things much faster. So instead of having to 3D print housing, or instead of having to like build a model of a house out of cardboard or foam or anything like that, they can just snap together Legos, which they're already super familiar with, and get going much more easily, much more quickly, and in a way that is fun and they'll be excited about. So I love that as a part of this kit and as a part of what's possible for beginners when they're using electronics. When I first started learning electronics, I was sitting with an Arduino at a desk with a computer where I'm reading the instructions, and I'm hooking wires up on a breadboard, and there's like spilled resistors everywhere. And at the end, it didn't look like anything other than an electronics project. So even if it was the same stuff that's happening in this picture, even if it was, detecting motion or proximity, even if there were buttons or lights, it didn't look like a house in the way that this looks like a smart home prototype. So I really love that this, brings things more to life and makes it easy. And I really think that permeates sort of everything that we're doing here with these products. And that's a fairly simple overview of the electronics kit. And we'll look at it in a little bit more detail and what it's like to use that when I start doing some demos. But right now, I want to talk about the next product that takes what we're doing with the electronics kit and expands on it and takes it much further and allows it to do much, much more. And that is our robotics kit. The robotics kit follows the same basic principles as the electronics kit, which is to say you take the pitop, you connect it to a plate, in this case, the expansion plate, which is like the foundation, it's like the foundation plate that's in the electronics kit, but it has additional capabilities. So you'll attach the expansion plate to your pitop, and now it can transform from a computer to a gadget to a full-fledged robot. You can see there a rover configuration for our robot, and we've written lessons for this, teaching people as young as middle school, honestly, to do things like computer vision, machine learning, artificial intelligence, all sorts of really advanced topics using this device in a classroom really simply. I think that those topics are amazing, and this is something that my whole life I always wanted to get into. I wanted to be a part of sort of the robotics building community, and it was very intimidating for me. And what I love about this kit is it opens the door in the same way that electronics kit does. It makes it much simpler, much friendlier, and much quicker to get started with those really sort of complex and advanced ideas, and that's really exciting. Right now, we have two sort of pathways that we'll talk about later. That the first one takes you through building that robot and allowing it to interact with the environment around it. And another one allows the robot to do things like recognize people, detect emotions, and respond to you and behave based on how you're acting. So you can do some really amazing stuff with it. These are some of the configurations that you can build in those challenges and in those courses that we've developed. So you can see the rover there, and then the one on the right is what we sometimes refer to as like a pet configuration. That's the one that's going to interact with you. And then the one on the bottom left is able to interact with the environment around it by gathering up different colored balls and organizing them and sorting them. You could technically train it to recognize all sorts of different things and pick them up and move them around. You can have it clean your room if you spent enough time documenting everything and doing the programming. But these are just 3 of the 5 configurations that we've designed for it. Beyond that, because of the fact that this thing can be taken apart and reassembled, you can design your own configurations for it that maybe don't look like a robot at all, or don't even use all of these pieces. You could build something that doesn't use the wheels or doesn't use the cameras. It could totally transform in a lot of different ways beyond even what we've imagined. You can see a little bit closer look at that kit here. So these are all the components that are going to come with that. Including the colored balls that we were talking about earlier that it can sort and identify, tape for line following, everything you need to do the projects that we talk about. You've got it all right here in this kit. All of the components are very clearly labeled and very carefully designed, I should say. You can see there the motors are attached to robust metal plates. There are 2 different types of motors here, and what I really love is that they use different pins. They use different ports to connect. So it's literally impossible to accidentally grab the wrong type of wire and connect it. I couldn't take the wire from one of the motors and accidentally plug it into the other one. I couldn't take the motor from the ultrasonic sensor and accidentally plug it into one of them. So it's a great kit for beginners who, especially, if you've got young children who aren't always wonderful at reading the directions, it's as simple as it could possibly be for them to build something pretty complex and do really amazing things with it without you having to be afraid that they're going to break some expensive thing that you bought for them. So I think that's really wonderful. You can see here what the process of building that robot looks like. So each of these metal components are held together with rivets, plastic rivets that you can take off really easily with the tool that we have there. You can put them back on so you can build it into different configurations. Snaps together really easy, but stays together very sturdy. I've actually built things before and then tried to take them apart without the tool, thinking like, oh, I'll just snap this apart really quickly. It's challenging because of the fact that we don't want it to fall apart while you're in a classroom with it. So it comes together really easily and it comes apart really easily with that tool, but any other times when you don't want it to come apart, it's not going to. So it's a very sturdy kit. So you take those components, you assemble them all together, and then you add the motors and the camera and the sensors to it to complete it. And then once your robot is complete, you attach the pitop on there really easily. It's going to snap into place with a satisfying click. And then you're ready to start building your projects with it. Again, things like line following and object recognition and maze solving, all sorts of stuff. And all of these lessons that I talk about, if you're saying this looks cool, but I don't think I know how to do this, or I don't know if my teachers are ready for this, all of these lessons are things that we have carefully designed and that you can take a look at right now. Actually, you could, as soon as you get off this presentation, you can go take a look at these lessons because they all live within our learning platform, which is our next product that I want to talk about, and that is called Further. So Further is our online learning platform where we house all of the curriculum and all of the content we develop for people wanting to learn electronics and coding with the pitop 4 ecosystem. You can see it here. This is the front page of Further. These are the courses, which are curated sets of lessons. So you can pick a la carte lessons that are standalone, but these are also ones that we think are great in a classroom where there's a start point. You go through multiple lessons that sort of build on each other, and then there's an end point to that. You can see we have all sorts of different courses here. And then beyond that, we've got extra lessons as well. This website is designed to make it super easy for you to take those kits that we were just looking at and do all of the things that I'm talking about and more with them. Each one of those kits is going to have specific lessons designed for it. And all of these lessons are designed so that if a student has never done this stuff before, or let's say you had a kid at home and they weren't even in a classroom environment, they didn't have a teacher there to facilitate, the lessons are all still designed so that those kids should be able to go through those lessons and understand what's happening and have success with them. We want to hold the hands of beginners through this process so that they can learn on their own independently with this. That's how simple we want it to be for them. But we also know that they're going to be used in a classroom. And if you are a teacher and you say, well, my kids have never done this, and then on top of that, I've never done this, so I'm going to have questions. We're not just going to hold the hands of the students. We also make sure to hold the hands of the teachers. So we have teachers' guides for all of the lessons on Further. We're developing those right now. And every time we come out with new lessons, we make plans. We're going to start rolling out guides for those as well. All of these guides cover the standards. They talk about what the students are doing. We give you sample code in case you don't know how to do Python and your kids are having questions. We highlight the code. And then we give you explanations and estimates on how much time it's going to take. Really, everything that you need, we try to think of it and put it inside of these guides so that you can do the things that you need to do in a classroom, so that you can do the things we tell kids they're going to be able to do in a classroom. These guides with those lessons connected to our products are going to allow that to happen. So that's a big promise. Let's take a look at a little bit of what that actually looks like in a classroom setting. So what I'm going to do now is a very risky thing in a live demo or in a live webinar. I'm going to close my presentation and we're going to take a look at what some of that actually looks like in action. So you should just be seeing my desktop there. And now let me do some stuff management to make sure that I've got my browser window. Okay, cool. There's my browser window. You should all be seeing that. Hey, come back here. There we go. There's my browser window, and I'm on Further here. And what I'm actually going to do is I'm going to open up our foundation tutorials. And I think I might have already done that. Look at that, I did, our foundation tutorials. So these are the foundation tutorials, and they are a great way to sort of get a first glimpse at how interacting with our products and our content on Further, how that works and what that looks like. So I'm going to do the LED tutorial here. You can see a check mark next to it because I do it a lot. But I'm going to do our LED tutorial. If you have a classroom of students who are getting hands-on with the pitop, or if you have teachers that you're training with the pitop, this is a great first thing for them to do. And I clicked into this really quickly, but the way that you'll find those tutorials is actually you'll go to Further, and then you'll click on these dots right here, and you'll just go to Foundation Tutorials. So I'm going to do that LED light tutorial right there. And I'm actually going to, no, yeah, I'll move it. There we go. Okay. Sorry, having to manage so many windows. Okay, so I've got the tutorial pulled up there. And the other thing that I'm going to do is I'm going to switch from you looking at me to looking at my pitop, which I'm also looking at, because I'm going to keep doing this and looking down at it. So I want you to be able to see it too. So give me just a second to switch my camera. Let's test that. Perfect. Okay, we're seeing my pitop and my robot and my tripod. Okay, so there's my pitop. Let me make, yeah, that's a little bit better. I've accidentally bumped my camera, so everything's crooked, but this is fine. So I've got my pitop right there, and on the screen, we're seeing the lesson in further. We've got this foundation tutorial here, and what it's telling me to do is connect my pitop to the foundation plate. That's the plate that I talked about that comes with the electronics kit. So I'll grab that plate. You can see it here, and I'm going to snap it on just like it says to do in the foundation tutorial there. So I've got that plate connected, and I will hit next. And the next thing it says to do is to get an LED and a cable out of our electronics kit. So I have my electronics kit here. Here's that bento box. We can see all the components inside of it. I'm going to move this aside for a second so you can see that. Actually, yeah, there we go. So those are all of those components. I'm not going to move these because I've already got them all nicely organized in there, but I do have some spares. So I'm going to move this out of the way. And I'm going to grab the LED that they have requested and the cable. Okay, so I've got both of those. And I'm actually, in order to keep everything organized, I'm going to put them on the lid of that plate. And it's telling me to connect this to the ports. So all of these ports are color-coded and clearly labeled. Actually, all of these colors are designed so that they are easily distinguished by people with color blindness. So all of these ports are going to be really easy for students to use. And this is a super quick and easy way for them to get started with electronics, because it says here, all I need to do is connect to port D1. It shows me what color it is. It's that magenta. I find it here and I plug in that cable. Okay, so I've got that cable plugged in there, and then it says to plug the other end into my LED. I have my LED plugged in there. So let's see if I can arrange these things nicely on the camera. Oh, there we go. Everything's kind of reversed for me. Yeah, it's fine. Okay, so I have both of those connected, so I'm going to hit next. And now it's telling me to connect my pitop. So I'm on my Mac right now doing this presentation. We are looking at my browser window on the Mac, and it's asking me to connect my Mac to my pitop. So this is what I was talking about when I said that we could connect to it wirelessly and control it wirelessly from a different device. So from my Mac, what I'm going to do is, it says disconnected. I'm going to click that pitop icon, and I'm going to type in the address on the pitop screen. So on my pitop screen right here, I can see that it's got my IP address, and I've already typed that in here, 192.168.86.39. And I'm going to hit connect, and it's going to connect to my pitop. So now my pitop is connected, and it says now it's time to press run to see if the LED turns on. So you'll notice at this point, we've not asked the kids to learn anything about this code. What we want them to do right now is just try it. We're not worried about them knowing the code or even trying to know the code, because a lot of kids who come to this for the first time, they might be intimidated. They might be unfamiliar with it. And if we start asking them to do some really difficult stuff right out of the gate, they might be hesitant. And we don't want that. So what we're saying is, look, here's some code. You don't have to understand it. Let's just run it. And I've done this with kids as young as 7 or 8 years old. And they hit run and the light comes on. And even though they didn't do any of the coding, they hooked it up themselves. They connected it, they hit run, they made that light come on, and they get excited. So again, kids as young as 7 to 10 years old doing that, they get really energized by it, which is great, because the next thing that happens is, you'll notice on the screen now, it says the code has turned the LED on for 4 seconds. Can you change the code to make the LED stay on for 10 seconds? Remember to press run once you've changed the code. So again, this is code that these kids have never seen and probably don't know how to read if they're that young. But as long as they can read, they can look at this hint that we've given them here that says sleep 4, and they can say, well, it stayed on for 4 seconds, and now I want it to stay on for 10. I should probably change that to a 10. A classroom full of 3rd through 5th graders, all of them figured that out on their own without any facilitation from me in a couple of minutes. So they hit run, and sure enough, the LED is going to stay on for 10 seconds. So at this point, I'm able to say to them, maybe you've never hooked up electronics before. Maybe you've never run Python code before. Maybe you've never edited Python code before, but now in a matter of minutes, you've done all of that successfully. And that's really exciting. The last thing is my favorite part of this because it says, now try to make the LED work on port D0. And this is really fun because we've not told them anything about that, and we've not given them hints in the way that we did when we asked them to change it from 4 to 10, but they've had a few successes under their belts at this point, right? Like they've hooked everything up correctly, they've gotten the light to turn on, they've changed how long it turns on, they're feeling confident. And it's always funny to me to watch kids take that energy and go, oh yeah, I can do that. It was on port D1. So all I have to do is change it to port D0. That's easy. This is nothing. And then when they hit run, nothing happens. And this is very fun if you're in a classroom because the kids will all start raising their hands and they'll be saying, not all of them, some of them will figure it out, but a lot of the kids will raise their hands and they'll say, mine didn't work. Did yours work? What's going on? We need to fix it. What should I do? And I say to them, well, what did you do? And they said, I took it from port D1 to port D0. I plugged it in and I look at it. I go, yeah, you did that correctly. What else can you do? What else can you try? Well, all they have is the hardware and the software. So the only other thing that they can do is go back to the code. They'll remember changing the 4 to a 10. So now they're going to say, well, what else can I change? And there's only one spot in this tutorial that says port D1. There's a big purple D1 right here. And every kid in a class of 3rd through 5th graders that I worked with was able to figure out, we need to change that to port D0. So now, and sure enough, it does turn on. Now, in less than 10 minutes, I've been able to unpack these in a classroom of students or teachers who've never done these things. And we are able to go through a really simple process where they run their first Python code, they edit the Python code, they hook up electronics, they change the way the electronics are hooked up, they start doing stuff without really any guidance at all. And when it goes wrong, they troubleshoot it, they solve the problem, and they make things work for themselves. That's a really powerful thing. And it's not even what we're really here to do. We're here to teach them coding and electronics and Python and all of these other things. And they're not learning those things in this tutorial. What they're really learning how to do is use the pitop, use further, and not be afraid of this stuff. And for so many people, I actually think that first step of not being afraid and being willing to use these strange devices and this code that you don't understand, just getting over that fear is a really big part of it. And that's such an important part for us when we're designing these things, is how can we make it as easy as possible at the beginning for people to just get the ball rolling and get over the fear and get excited about doing it. So that is a really big part of what we think of when we're designing our products and our content. So once we've done that, once we've had that success, it says, great, you can go try some of the other tutorials. Sure enough, if we hit done here, it says, try these. Or if you're something ready for something more advanced, you can maybe try our Robotics 101 course. We actually have, as you've seen, a ton of courses. If I go here, I can look at courses for our robots. I can look at courses for our electronics kits. We actually even have courses that just use the pitop by itself with no additional components. One just for using the pitop, and then one for just using the pitop. And then doing game development with it, making retro games on the OLED screen on the pitop. All of this stuff is for teaching hardware electronics and Python coding, but we also want to make sure that we're doing things for younger students, which is why this year we've released BlockPy challenges. And they use all of the exact same stuff and the goals are the same. The only difference here is rather than using the Python code, these are going to be using block-based coding similar to Scratch or what they might have done with Hour of Code or some other coding and electronics kit. This is going to allow kids who are even younger to work even more easily through this stuff. It's a great way to transition kids from things like Scratch to using hardware, and also to transition kids from using Scratch to using Python code, because our block code looks a lot like Python. So you could take a kid from Scratch to our block coding, and from our block coding to Python. And each step along the way, you're gonna go, this is a little bit different than the thing that I've done before, but it's familiar enough that I feel like I can do it and I'm willing to give it a try. And that's kind of our goal by adding block-based projects. Another thing that I really like about these, let's look at them really quickly. All of these block-based projects that we have, they focus less on the engineering some elaborate gadget. We're not building and driving the robot here, and we're not building these large projects. Most of what we're doing in our BlockPy projects at present is actually more akin to an art project. So in this one, for example, our curriculum designer, Marielle, is a fantastic artist, and she made a coloring sheet depicting our robot exploring an alien planet. And the students get to color that in, turn it into a piece of art, and then add the electronics into it at the end. Similar to how we try to make things in our coding really easy for beginners, this is us wanting to take people who have maybe always been scared of this stuff, never wanted to do code, never had any sort of interest. People like me when I was younger, who were really into the arts and didn't think they could do this stuff. Even though I wanted to do this stuff, I didn't think that I could. And people like that, these are projects to sort of make that a little bit easier for them. So if we look here, we can see what that finished project is going to look like. It's more of an art piece than it is a gadget, but it does have those electronics components, and you'll see that it does have that code. So this is a great way to take people who are complete beginners and also maybe unsure of themselves and bring them into this stuff. You can see we go through step by step through the lessons. Like I said, we're really interested in holding their hands through these things. We take them step by step through the lesson. We give them templates to print out and to cut. We give them instructions on how to assemble everything. At the beginning of this, there's no coding or electronics at all. It's like how my parents used to sort of like hide broccoli and spaghetti sauce because I didn't want to eat it. We're sort of doing a bait and switch here where we say, come on, do this art project with us. It's super simple. And then at the end, we say, great, now hook up a computer and add some lights to it. We're sneaking the STEM into the STEAM, into the art projects. So now we're saying, great, you did all that part, that was easy. Let's really easily connect these lights, plug them in, connect the pitop, and here's some code. And once again, they don't have to know the code. They don't have to understand the code. We say, here's some code, run it, and your art piece is going to come to life. It's going to have light. So even if they never get any further than this, this is going to be exciting for a lot of kids. They made a piece of art and they made it light up. And hopefully what that will do is the next year when they come back, they'll say, yeah, that was fun. I wasn't ready yet, but now I'm ready to try a little bit more of the complex stuff. And we can start challenging them and saying, like, how can you change this code so that the light is activated by a button? How can you modify the code's behavior and add other things to it, add new sensors so that it's not just lights coming on, or it's not lights coming on when you press a button, but maybe, you know, the lights come on when a person walks up to it or when they wave their hands past it, or can we add sound to it? You know, there's all sorts of different things that we can sort of build up to as long as we get our foot in the door and get them interested. And that's what things like these lessons and block coding are for. And honestly, that's a lot of what the pitop itself is for, is to take a sometimes intimidating field and make it easier and more accommodating for beginners. So I really like to show off the lessons every chance I get. I just realized I hadn't switched back to my camera, which is totally fine. You don't need to see me, but I'm gonna do it just because I'm not doing anything with the pitop at the moment. The other thing that I really want to show off is our robotics kit. You know, we're looking at the stuff for younger kids here, but I want to look at stuff for the older kids as well. And I say kids, the robotics kit is something that we designed for middle and high school, but I know it's also being used even at a university level. And you know, there are plenty of people for whom this might be their introduction to robotics, even if they're an adult. And it starts off really fun and simple. And like I said, it goes into really advanced stuff. So I'm saying that, you know, this is something for older kids, but really this is something for 6th grade through university and up. The robotics lessons start by focusing on building the robot and then teaching it to drive around. You know, actually we can see, I think I've got that robotics code open here. The very first piece of robotics code that we see here, all it does is tells the robot to drive forward. And you know what, my robot is right here on the desk. So now I'm gonna switch back to that other camera. Let's take a look at that really quickly and see if I'm gonna roll the dice and see about making another demo happen too. Okay, so what I'm gonna do is I'm gonna take the pitop off of my foundation plate there, and I'm going to connect it to my robot. And I tinker because I love this stuff. And so my robot is not in the same configuration as everyone else's. So it has claws on the front, and it actually has 4 motorized wheels rather than 2 motorized wheels. So it's a little bit different, but I think we should still be able to at least get it to drive. So what I'm going to do here is I'm connected. I've got this test code up, and I'm always messing with things, so this might not work. But let's see if I can get the robot to at least just drive forward. And it's only going to spin 2 of the 4 wheels that I have, because right here we're only telling it which wheels are left wheel and which wheels are right wheel. And I might have even hooked them up backwards because I don't follow the instructions. So we'll see what happens. So let's go ahead. It's probably going to crash into my camera, which will be really funny. Yep, that's exactly what happened. Good job. You can see the wheels turning there. Now it's driving backwards. So that was super simple. And you saw that, oh my gosh. Let's tell it to stop there. Calm down, buddy. I accidentally ran it twice. So that was super simple to make happen. And you can see that all I did was I took the pitop off of the foundation plate, connected it to the robot, and it was ready to go, which is actually a great example of how you could use these things in a beginner class, and then the bell rings, your advanced class comes in, they could take the exact same pitop, snap it off of one device and snap it onto another, log out of, if they've got their own Chromebook, they don't even have to log out. They open up their further lessons, which are going to be different from the beginner class. They're just ready to go. It's super, super simple to connect to these things because of the fact that we're doing it through the browser on any device over Wi-Fi, and then you can just connect and go. It saves all of the code that the students are doing. So if you have a student who's been working on these robot lessons, and then they get interrupted in the middle of it, they can come back the next day and it's going to be right where they left off. You can share them back and forth. It's really, really simple. But the other thing that I did want to show about these robotics courses, like I said, they do start with just driving the robot forward like we saw there. And then we go into adjusting its speed, learning to steer it, learning how to drive through a maze, things like having it know when it's getting close to an object, so it will stop, getting it to follow a line using computer vision, using its camera. You can see the camera for mine on the front here, right? So that's a module just like the rest of ours that we have in our electronics and our robotics kit. You can see the ultrasonic sensor here, so it can detect locations. Mine is actually a combination of two robotics kits put together, which is why it has 4 wheels and 2 claws on the front, all sorts of elaborate stuff on it, because I'm doing goofy stuff with mine. But it goes into all of these advanced topics, and that's just in the Robotics 101. You could spend a whole semester just on this stuff. And then the Robotics 102 will take users into advanced things like computer vision. So recognizing people's faces, you can have it recognize a face, but then also recognize emotions. So if you're happy, you can have it behave a certain way. If you're sad, you can have it behave another way. In the behavioral enhancement lessons, it can actually check to see whether or not your eyes are open. So, we've got a picture of a person driving there. But for practical applications for students, we can imagine using this so that while a student is studying, if they start to fall asleep, if their eyes close and the robot is watching it, it can whistle at them to wake them up. You could even just make it so that the robot drives forward and pokes them so that they wake up. So there are 2 really different sort of subject matters happening here with the same robot in 2 very, very different configurations. And I think that that's really awesome. But what I also always like to talk about is the fact that the lessons deal with different subjects in terms of the 101 is about navigating the environment and the 102 is about interacting with people. So once again, just like how we talked about, if you have someone who's maybe interested in art, but they're not interested in STEM topics, we can bring them into that. This is where we can say, the rover robot can be programmed as a security device, or it can be programmed to, explore Mars and be controlled remotely from a computer at a distance. Whereas you think about things like, smart home speakers and smart home devices and the robots that we interact with, those fill an entirely different role in our lives. They're not like off driving in the distance by themselves. They're directly interacting with people. So you can have 2 very different groups of people interested in very different subjects learning about this. And we've actually seen that in studies. There are studies that talk about how when a robot looks like a car, female students are less engaged or less interested, whereas when a robot has a face and when it interacts with an individual, that engagement with females actually goes up. So, in a STEM where we're always talking about how do we increase engagement for girls and young women, just designing the lessons around things like that and just knowing what different groups are going to be drawn to is super important. So I'm really happy that we have both of those. So that is a live demo of what it looks like to use the pitop. You can imagine this in a classroom. The kids are sitting at their desks, the robots are on the floor, they're connecting to them wirelessly from their Chromebooks, they're driving them around, interacting with each other. But another thing that I want to talk about with these lessons and with students using them is the content of them is designed with very specific ideas in mind that I think are really wonderful for encouraging not just learning computer science, but learning a lot of different skills. So the next thing I'm going to do is I'm going to go back to my presentation to talk about that design philosophy when it comes to the lessons. Okay, So in all of our lessons, and you can kind of see a little bit of it in the foundation tutorial that we did, and even in the robotics lesson there, where we had that sample code where the robot drives, and it's not even asking you to write any code or to understand any code, you're just trying it. You can see hints of our design philosophy for our lessons. And that design philosophy is something that we call assemble, tinker, play, and share. And in this, they go through different phases, and sometimes they will repeat phases over and over. The assemble phase I always compare to if I gave everyone the same Lego set. I gave a group of 5 kids each their own Lego car and said, follow the instructions and build that car, right? So they're each going to build their own. They're each going to follow the instructions. And at the end of it, we're going to have 5 Lego cars that all look exactly the same. And then Lego is a great way to think about this, because the next thing that people do naturally is they start to take the things that they learned when they were building that car, sort of the design ideas and the construction ideas about that car, and they start to tinker with them and change the thing. So one person will say, maybe I can take this part off, and instead of being this thing, it can be this thing. And someone else will say, maybe I can change it in a different way. And it's still the same kit, and it's still the same parts, and it's similar, but they're all sort of starting to evolve in different directions as students are taking the information that they absorbed in the build process and applying it and really making sort of concrete learning from it. We might go through those phases multiple times. You might teach someone something and then have them tinker with it. And then you might teach them something new and have them tinker with it, and do that over and over. And maybe those things scaffold and build off of each other. So we can think about teaching someone to hook up the LEDs in the foundation tutorial, and then teaching them to run the code, and then teaching them to change the code, and then teaching them to change how things are hooked up, right? We went through really specific instructions where everyone's going to be doing the same thing, and then we asked them to start tinkering with it. So we might go through those loops several times within a challenge before we get to a play phase where we say, cool, you've done the things that we asked for. Now you pick something. And we saw that very briefly when we looked at the block-based lesson with the coloring page of the robot, where at the bottom it said, great, you've turned on the lights and you've made them work with a button. Can you make them work with the ultrasonic sensor? Can you make it where not only do the lights come on, but a sound plays? What other things from outside of this lesson could you explore and bring in that you're interested in? And the play phase allows the learners to sort of bring their own interest, or bring the things that they're curious about, or bring the things they want to try into the lessons that they've just done. So at this point, they've achieved all the goals that we had for them, and now they're getting to do new things and explore it. And that's going to really excite them and encourage them to keep trying. And like I said, it's going to cement the earlier learning because they're going to be applying it to other things. And then finally, we always include a share phase in that, where at the end, after they've gone through that play phase, after students have tried their own thing, they've tried something new, they come back together and they share that with their friends. They say, I was interested in this thing, so I took what we built and I did this with it. And the other friend said, oh, I was interested in this thing, so I took it and did this with it. And they're listening to each other and they're learning from each other. And this is really wonderful because at this point, they become the teachers and you as the teacher just get to become the facilitator. I think that that's really amazing. We think about it in all of the lessons that we design. We think of different ways that each of those phases could happen. Connecting a sensor might be an assemble phase. Trying to mount it in a different place would become a tinker phase. Adding new sensors or different parts becomes a play phase, and then compete with others to see which combination works best to achieve your goal to be a share phase. That's one way of doing it. You can do it in totally different ways without building stuff for the pitop, right? Read these 3 articles and answer these questions is an assemble phase. Everyone's reading the same articles, everyone's answering the same questions. And then we say, find 3 related articles. So everyone's going out and finding different articles related to that thing. And then someone else says, find other information and write your own articles. So now it's getting totally different. So that's the same assemble, tinker, play, share, but applied to a totally different area. And we can see a sort of visual version of that. Like I said, everyone starts off with it looking exactly the same. They slowly start to transform those things as they go through a tinker phase. It evolves even further into something completely new in the play phase. And then they come back together and ask questions about how can we connect these things? How can yours fit inside of mine? What's the difference between each of them? All of this stuff goes back to, very early constructionist learning. Things like the work of Mitch Resnick and the lifelong learning group at MIT and the design thinking spiral. All of that is baked deeply into how we're thinking about these lessons. And it's really just the beginning of the things that you can do with pitop. We're running out of time here, so I don't want to talk forever. I do get excited about it, but what I want to do now is actually pause, take a break, and see if there are any questions. And if not, we'll invite you to come back for our next one of these in, I believe, 2 weeks. So I'll pause here and see if anyone has any questions. And thankfully, I'm going to be looking down my other screen now because I've got the QA open here and I've got the chat open here. It looks like we're all good. But we do have a raised hand. Let me see if I can allow you to talk. Okay. If you have a question, feel free to unmute and ask that now.
Hi, thank you for a great presentation. My question is how easy it is to expand on top of the pitop for more like professional projects. How easy it is to just add different sensors, maybe from Seed Studio, or maybe just some normal Raspberry Pi sensors on top of it?
That's a great question. So I said that I could talk about this forever, but I was going to stop to make sure that I answered questions. The part of my presentation that I stopped at, the very next slide was about adding other stuff to it. So actually, I'm going to open that back up and hit share really quickly to show you the exact answer to your question. So give me just 1 second to do that. Okay, so I'm going to share my other screen again. I love that that was your question, the first question that we had. That's great. So I'm going to share that desktop. And the next thing I'm going to do is I'm going to hit play on that presentation so you can see it. So what we see here is the exact answer to your question. You were asking how easy is it to add other sensors, maybe something from Seed Studio. And I was like cheering at that. These are sensors from Seed Studio's Grove sensor collection. And they work out of the box with the pitop electronics plate, or the electronics kits foundation plate, and the robotics kits expansion plate. So I have taken all sorts of sensors from their kits, plugged them in, downloaded the code that they offer on their website, installed that on the pitop, and got it running. Super, super easy to do that. Yeah, any of their stuff will work directly out of the box. There are tons of other places with similar things. Before this part of the presentation, the other stuff that I left out was all about connecting other things to it. So you can see in these pictures, you can see that I'm accessing the GPIO pins in the same way that you would on a regular Raspberry Pi. We've actually got labeled GPIO ports on the top. So anything that you needed to plug in, if you wanted to use the Raspberry Pi Foundation's lessons and they're saying plug something into pin 13, not only do you have access to that pin in the exact same way, but it's actually easier than it is on a regular Raspberry Pi because of the fact that we've labeled those pins, which is always something that drives me crazy about using a Raspberry Pi, is that none of the pins are labeled. So we've actually made it easier to do regular Raspberry Pi projects than using a regular Raspberry Pi. Because of the fact that this is powered by the Raspberry Pi 4, any project that you can do with a Pi 4, you can probably do with this unless there are size constraints. The pitop has a battery, a speaker, all sorts of additional components, so it's larger than a Raspberry Pi. But if there's not a size constraint, like if you're just plugging a Sense hat or a WaveShare screen or any sort of standard Raspberry Pi accessory in over the GPIO pins, you're going to be able to do that out of the box with the pitop. And you can see here, I've plugged in other devices. I have in those pictures a microbit connected to it over USB, but I can also connect the microbit to it over GPIO. I can connect an Arduino to it over GPIO. Anything that can connect over USB, like little bits, or earlier in this, I've got, I show how we hook up a Makey. Anything that you can hook up to a Raspberry Pi, either through the GPIO or through USB, you can connect here. And actually, even on our robotics, on the expansion plate that comes with the robotics kit, we have a second space where you can plug in GPIO pins. You can either plug them in on the top, or you can plug them in on the robot. So it's a very flexible system for that. Great question. Any other questions? I'm so glad that I got to talk about that. I was like, oh no, we're running out of time. I'm not going to get to talk about all the other cool stuff you can do with it. And you really set me up with that one. Okay, well, in that case, we are at time. So thank you for that question. Thank you for attending. I'm going to go ahead and stop the recording here.